So from this particular session, let's start with the new topic, which is SystemVerilog Assertions, and let's try to understand what do I mean by this SystemVerilog Assertions and where I'm going to use it and how I'm going to use it. Let us try to understand and let's have a look into it. And give me a second. Let me share my screen. Yes. So before that, you can also watch the System Verilog sessions if you haven't watched it. All the recordings are available, and we have also completed the project on decoder-based RAM verification, and we are left with a few. Uh, we are left with some functional coverage part which we need to add in that, and we are going to complete it soon. But the major part has been completed, writing the test cases, running your regression test, and how to build it and all. We have completed them, so you can refer them if you want, right? Now, coming to this system verilog assertions. So basically, these assertions are one of the most important concepts in VLSI verification. And in our semiconductor industry, almost every complex processor or interconnect what we are going to have and all uses this particular assertions extensively. Now, what is the reason for them? Basically, these are used heavily in IP verification or SOC verification or formal verification or protocol checking or CDC verification and all, right? Now, so what do you mean by an assertion? Basically, this assertion is a statement which is going to check whether a particular condition which we have written is being satisfying or not. That's it. Okay, that is nothing but an assertion. And give me 1 second. There is some disturbance over here. 1 second. Yes, I was having some disturbance over here. Yeah. So coming to this particular assertions, these are going to check whether whatever the condition which we have given, it may be any condition, it may be timing condition, or it may be a simple Boolean expression condition which we have given, whether that particular condition is being satisfied or not, it is going to check for us. Okay, that is nothing but my assertion. So basically, assertion is a statement written inside the design or verification environment. It can be written inside your design or outside your design also. That is going to continuously check whether a particular condition or a property is true or whether that particular condition is being satisfied or not during the simulation or formal verification. So basically, assertions are automatic checkers that monitor the DUT behavior instead of manually checking through waveforms every time. Assertion detect protocol violations or design bugs automatically. So what have we done till now is if a particular design is working correctly or not, we use it to run it. We use it to check the waveforms. We use it to check the console and all. But here, assertions, what they are going to do is if they have encountered any particular error in a particular line, they're going to tell us that we have an error or we have a warning over here. Like that, according to the severity level, we are going to get the check of whatever we are going to have, right? Now, for example, let's say if we have a condition, like let's say suppose we have a handshaking mechanism of two components, where first component is giving you some signal which is known as request and another is known as grant. So let's say this particular second component is sending the request signal and the first component will give the grant signal. So this is a handshaking mechanism which we have between these two particular components. Now let's say whether whenever request becomes high, grant should become high within 2 cycles. This is our requirement and this is some protocol specification which they have given. Okay. So according to some particular protocol, whenever this particular request has been given, grant should be given within 2 cycles. That is a requirement. Now, whether this particular requirement is being satisfied or not, if we want to check, then we can use an assertion and we can check whether this particular condition or whatever the timing condition we have, right, that is being satisfied or not, we can check it. So instead of visually checking the waveform, we can basically write down an assertion and we can check whether the condition is getting failed or whether the condition is getting passed. If the condition is getting failed, we can report an error into the console and we can report assertion is getting failed. So using this, you can know exactly which condition is getting failed and which particular line your particular condition is getting failed. You can basically easily debug. That is the use case of our assertion. Is it clear, guys? Any queries in this? Okay. Hope it is clear, right? Yeah. Now, so the difference between your assertions versus traditional verification is in the traditional verification, you need to write down the simulation, run the simulation, open the waveform, and you need to manually debug it. But in the case of your assertion based verification, you're basically going to assertions are automatically going to monitor the behavior. If a violation is detected, then it is going to inform us immediately, and it is very easier to debugging, and it leads to higher coverage. So this is the use cases. This is the difference between your assertions and traditional verification. Now, who is going to write down this particular assertions in industries? We, as a design and verification, you can write down the assertions, and even the RTL designers will also write down these assertions. Whenever they are writing down the design code inside your design, only they are going to write it down. And where are these assertions written? So who is going to write down these assertions? It is clear, but where we are going to write it down? So we can write down inside a module. So whenever we are going to write down a code, in that only we can write down our assertions, whatever the conditions. Assertions, don't think of it as a complex terminology. It's nothing but it's kind of a condition checking. That's it. So assertion is nothing but it's kind of a condition checking. It is going to check whether whatever the condition is being given is passing or getting failed. That's it. So it is going to continuously monitor it. And it can be written inside your RTL code, and or else it can be written outside the particular RTL code. Let's say this is RTL code, and this is one more file where assertions is being written. You can bind this two files. So this is nothing but binding that we are going to see in our later sessions. So like this, we can write down the assertions inside your RTL code or outside our RTL code. And what assertions can check? Assertions can check protocol timing, FSM transitions, handshaking rules, FIFO overflow and underflow conditions, arbitration, reset, and etc. So this is where you can think of having assertion checking. Yeah, you can think of this particular example where your FIFO should never write when full is equal to 1. Obviously, now, so if the FIFO is full, then you should not perform the write operation. This is the particular condition we are going to have. So for checking this particular condition, we can write down an assertion like this, which is basically going to check whether if write enable is equal to 1 and FIFO is equal to 1, then whether we are basically writing down any particular data or not, this assertion is going to check. Now, and you can also think of using assertion in AXI protocol where we have a valid signal and a ready signal. So this particular handshake, if this is happening or not, and when it is happening. So this also we can basically frame it in our assertion and we can check it out. Okay. So assertions are basic conditions which we are writing and we are checking the things. That's it. And you can think of this particular scenario where handshake valid must stay high until ready is being asserted. So this particular condition also you can frame it using the assertions. This and all we are going to see. And one more thing is what I'm planning is this particular system verilog assertions, instead of focusing more upon theory, we will take so many scenarios and we will try to write down those particular assertions for those scenarios, and parallelly we will try to understand and we will try to learn what are the system tasks which we are going to use, and all the theory concepts from the problems. That is what I'm planning. Okay. And yeah, so this is one of the scenario we have. So the rule over here is once the valid goes high, it must not go low until ready is high. This is the condition we are going to have in AXA protocol. We will have this kind of scenario where we have a master and slave. When this valid is equal to 1, then this should not be equal to 0 until and unless this ready becomes 1. So until and unless if ready is not 1, valid should not become 0. This is the condition which we are going to have. Now for this particular condition, we need to, if we want to write down the checking, this is how we are going to write down. We have declared all the inputs and outputs, and we have declared some two variables, which is valid was high and error underscore flag. So we have written a positive edge of the clock and we have reset everything, and here we are going to track it. So if valid is equal to 1, we are going to make the signal which is valid underscore was underscore high is equal to 1. That means we will come to know that valid is high. Now what we are going to do, when the valid is high, that is valid was high is equal to 1 and ready is equal to 0. And if valid is becoming 0, that should not happen, right? Ready, if it is equal to 0, valid should not become 0. It should be 1 only. But if it is happening, then we can display that error at particular time. And we can also make this error flag is equal to 1. So this is how we are going to write down the checking code for this particular AXI handshaking. Is it clear, guys, how we are going to write down the Verilog code for this particular handshaking? The checking code, it's a simple code. Is it clear? Anyone having any doubt in this? Hello? Yes or no? Okay, fine. Now, let's say if I want to write down the same code using my assertion, then this is the piece of code which I'm going to write down. And this is the main logic. So dollar rows of valid, implication operator, valid throughout, hash hash one colon dollar, ready. I will let you know what do you mean by throughout and what do you mean by hash hash operator, what is dollar, what is this particular symbol at all. But if you carefully observe, in a single line, I'm writing the entire checking logic. That's it. But if I want to write it down using Verilog, this is the code which I want to write it down. Okay. So this is where the difference between your assertions and normal Verilog coding checking are going to differ. That's the reason you're basically using assertions for basically reducing the code also, the number of lines you want to you are going to have for your code also. Okay. So yeah. So this is about your introduction to assertions and where you are going to use assertions and why you are going to use assertions and who is going to write down this particular assertions, right? So from next session, we will start with understanding what are the different kind of assertions which we are going to have and where the assertions are being executed, in which particular regions of your event scheduler these assertions are being executed, and how are they differentiated, and what are the kind of assertions we are going to have in the next session. And from tomorrow it's Friday, right? So from most probably Monday, we are going to take scenario like we are going to have a problem statement and how to write down the assertion for that particular problem statement. I'm going to show you, and from that we will try to understand what is that particular constructs. For example, I have given you this particular problem statement of AXA, right? So for this AXA problem statement, this is the answer we have. So from this answer, I will give you this answer, and from this answer, we will try to understand what is this keyword, what is this implication operator, what is this hash hash delay. So from the answer, we will try to understand the concepts. So that is what I'm planning of. Let's see how it is going to go. Okay. Yes. So that is about this particular session. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss with me, or else we can end this session. Okay. Thank you.